This is Dan Abbott. This is the second Weldment video. I'm using a part that I created in the first one, and I'm going to make a few changes to this part, then we'll add some configurations and then make a drawing. The first thing I'm going to do is to rename rectangular tubing, which is it got from the description in the welding profile. I'm going to just rename that and call it the frame. A little more descriptive. I'll come down to where it says tube square and do the same thing. I'll leave the size in there. I'll put my fingers in the right place on the keyboard and call this cross with the overall dimension. And this is tubing. So, okay. So that's now the name of that structural member. What I'm going to do next is I'm going to change the way this is dimensioned because I want to use equations to drive these dimensions instead of the dimensions that I have. So I'm going to go over to my equations. And if you don't have that showing, which you probably won't, if you go over to Tools, Equations is right down here with that Greek sigma, and you can pick that and get the same results. Now I did use equations in the last video to show you how to make the spacing be maintained. Those are going to be yellow just because of the way I did it. I did it by picking driven dimensions, and that just gives me a warning that I might have some problems with that. I have never had problems doing that, so I'm going to leave it alone. It's not a fatal warning, or it'd be in red. So I'm going to add a couple variables. First one's going to be 30, 40. Well, it's going to stay 40. So now I'm going to add another one, and the next one's going to be B, and that'll be the overall length of 120. Click OK. Now they've been defined, but I haven't used them. I'm going to go back to my sketch. This is my original sketch. I'm going to just delete the overall dimensions, and I'll put them back in. And when I put them in this time, I'll type an equal sign like I did in the last video. Say use the global variable A for the overall height of this. It comes in with the sigma in front of it showing you that it's equation driven, which means it has a global variable value that's driving it. I'll do the same thing with this. Type the equal sign, go down to global variables and pick B, pick OK, and I'll come back out. What that means is I can change the equations in the equation manager anytime and it'll change the overall size of this. What that allows me to do, besides just changing the size and then leaving it that way, is to create configurations. SolidWorks by default in a weldment creates two configurations, something called as machined and something called as welded. What I want to do is to add two more, and I'll just leave those the way they are and I'll delete the default later on. So I'm going to go to the very top level. I'm going to create new parent configurations by adding configuration. So I'll call this one 160 inches. Sorry about that phone ringing. 160 inches in width, and my description will be 160 by 40. by 40. I'll check that off in case I want to use it in a bill of materials. But now what I've got is two configurations, and because it's a weldment, I have one called as machined and one called as welded. I'm going to add one more. And this one I'll call 120 inches. I'll just say 120 by 40. Now I've got the first configuration, got the second configuration, and I'll make the 160 current. I'll go back over to my feature manager, and I'm going to manage equations, and I'm going to change those two values. So that this one, which is 40 right now, let's make that 30 so it gets shorter. And then the 120 we'll make 160 so it gets longer. But I have to do something that I didn't do to the first one. I have to go to the little drop down and say I want to apply this only to this configuration, all configurations are specified. I need to specify in a Weldment because I want to pick the one that I've created called as machined and the one that SolidWorks created called as welded. Now I'm going to go back up to the other equation, do the same thing, and make sure that I've done the same thing there, where it only applies to those two configurations. Now I've got this wide and short version. I come back over here, go down to 120, and rebuild, and I have a taller but narrower version. The default I'm going to get rid of because I don't want it anymore, so I'm just going to delete it. So now I've got two configurations that I can use. Let's just say I want to use the one that's 120. I also would like another configuration. I'm going to put this under the as welded configuration. I'm going to right click, I'm going to say create a new exploded view, and I'm going to do just like you do with assemblies. I'm going to do an exploded view, pull the pieces apart a little bit. I'll just take all three of those pieces for this one and do auto space. Now when I bring this down, it'll automatically space them out. And I can adjust that spacing if I want by using this slider. Just going to leave that the way it is. So now I can display this exploded. I can't work on it while it's exploded, but I can save it so I can see it this way, but I can also use this view in the drawing if I choose to. For working on it, I need to have it collapsed. So I need to go to the explode view underneath, right click, pick explode to explode it, right click, pick collapse to collapse it, and that explode view is under this configuration, 120 inches as welded, which is under 120 inches as machined. We'll make one other change just to show you some of the possibilities. I'll go back to the 160, rebuild it, and you will have to do a rebuild frequently with SolidWorks when you go back and forth with configurations. Not always, but frequently. You don't think anything happened, and then when you do a rebuild, it all changes. What I'm going to do is I'm just going to delete or suppress the cross pieces, but only in this view. So if I do that, now the visibility of those cross pieces has been suppressed. Not just the visibility, they are in fact suppressed. So now if I go back over to my configurations, when I return to the 120 configuration, it not only changes the overall size, but it also adds in the pieces that are suppressed. Go to as welded, looks like that. When I'm in as welded, I can explode it, or I can not. Now I'm going to go and make a drawing. Just before I leave, I'm going to go back to 160. Really just to make a point. So I don't have a drawing open yet for this. So I'm going to go to File, Make Drawing from Part. I'll use my template to do that. Actually, it's not my template because I don't have the right title block in here, so we'll just clear out the title block. Now I don't want to bring in the current view and have that stay, so I'll just make one view, highlight it, and then come over to the left, and under Reference Configuration, I'll say, you know what I really want is 120 inches as welded. And I want to change the overall scale of that, so I'll use a user-defined scale. Came in at 1:32. So in this particular drawing, I have ANSI set as a drafting standard. That's why those scales look like that. But I don't have to use those scales. I can type any scale I want, or I can change the drafting standard. Now when you start dimensioning this, you can dimension the overall height. This brings up something. That number was incorrect, and it's incorrect because I've not yet suppressed all those tangent edges. So I'm going to right click in the view, go to tangent edges and say tangent edges removed, so that I can put in a dimension that goes from that top edge to the bottom. Now that's 30 inches tall. From that corner to this corner, okay, that should be 120. And once again, even though you can't see them, you can see that I missed the actual edge, and I picked the tangent edge instead because both of them can show up. You can see there's a tangent edge in here. So you might have to be a little careful when you have parts with small fillets on the inside like that does have. Alright, there we go. So that's 120. Now I can also get the actual overall lengths of each of these pieces, and I can put those here if I want. Put each one of these here, put in the angles, just the way you would dimension any other part in SolidWorks. But I can also bring in what's called a cut list. Cut list is a list, like a bill of materials of each of the components of the weldment. So what I'll do is go back over to the part file first, because the part file shows the cut list in the feature manual, feature manager. And if you take a look at it, it shows you in this case what those tubes look like. But this is not the cut list that I want, because the view I had before was 120 inches as welded. So we'll go back to 120 inches as welded and look at the cut list. Now it has all those items in it. Now I can right click on this if I want, go to properties, and I can change some of the properties for each one of these pieces. I can add new properties in. I'll add two things. One is I'll add something called source, which is a SolidWorks property. I'll type in Acme, and I'll add a new one that's just going to be my own, manufacturer, say, which is obviously similar to source. It's also going to be text-based, and I'll leave that one blank. Now I come back out, right click on cut list, and make sure that it's updated. Now this updates automatically. That's the default setting. If that's turned off, and it does, sometimes people turn it off, you want to right click and then go in and select update manually. Go back over to the drawing file. Everything's fine in the drawing file. I'd set up the line weights and as you would for your standards, etc. But now I'm going to bring in a cut list by going to Insert, Tables. Under Insert Tables, I'm going to pick a Weldment Cutlist. I'm going to select this view as my cut list view, and then I'm going to make sure, and this is really critical, make sure that the configuration that it's associated with is the one that is actually showing 120 inches as welded. This is where most people end up being confused, because that comes in and it comes in with a different configuration set. You also want to make sure that the template being used is the cut list template and not the weld table template. You probably want to make your own custom template file for cut lists as well. When I pick the green check, it comes over here and I get basically a bill of materials with each of those components. Now there's another gotcha, and the other gotcha is, and in this view right here, if I right click on it and go to properties, there's a box called Link Balloon Text to Specified Table. Now it worked fine when it came in, but the fact is, if I had more than one cut table, or if I had different views in here, if I'd been working on it for a while, there's a good chance that the link between the balloons I put here and the cut table would be broken. So you want to check that off and make sure that the Weldment cut list that you want is the one that is actually highlighted here. Pick OK. Now I can go over to balloons. Normally I would do the balloons one at a time, but I'm just going to do an auto balloon here. The auto balloons come in, the numbers match the numbers on the cut list. If you do this correctly, now it's very easy to make a mistake and end up with a 0 or an asterisk, and at some point I'll make a video showing you what to do about that. But this one is about what to do when things go right. So each one of these components has now been identified with a number. The number matches up here, but you'll notice that my source column is not in here. So I'm going to right click, Insert, Column Left. Now I'm going to go over to the left and say my cut list item property that I want to put included is called source. I'm going to make this a little bit smaller, and you'll see the one piece that I actually put a source in, the word Acme, that shows up. So we'll make another insert. I'll go column right on this one. Come back over here to cut list property, and you notice under cut list property the manufacturer is in here, which is the one I put in as a user defined. Now this cut list looks like it's something that you could edit, but as it comes in, all these are SolidWorks cut list properties, which means if I double click on them, I can't edit them in the drawing. I have to go back and edit them in the same location where I put that word Acme. So I literally have to go back to the part file, and in the part file I have to right click on the cut list, right click on the tube, In this case I already did that, so let me go on this one. Look at the properties of that individual structural member. I need to add source to each one of these. It's text, and once again I'll type in Acme. No, I won't. Not there. Type it in up here. Acme. And I'll add manufacturing as well, which I'm just typing. And say I want that done by the Smith Company for some reason. Now I pick OK. Go back to my drawing. Now in the drawing, I have Acme shows up under that item, but manufacturer, I might not have spelled it exactly. And just a reminder, you have to make sure that under properties for this view that link balloon text to specified file has been checked off. Now I'm going to bring in a couple of other just drawings of parts. There are a couple ways to do this. One way is to go over to the view layout, and under view layout pick model view, double click on the Weldment, and then just pick selected bodies. So I'm going to say what I want to do is bring in a drawing of just that body right there. Now it comes in, puts it in place. I can rotate the view if I want by right clicking on it. But now when I balloon that, it's going to have the same balloon number as the part that I have down here. So, and that's number 1 because there are 2 of them. But there's sometimes a problem here as well when you bring that in, and that problem sometimes is the same. When you go to the properties of that view, you have to check and make sure that link balloon text to specified table is there. If you have more than one cut table especially, it's not going to know which one you want to associate with, so that's going to be unchecked. The other way I can bring in a view if you want, and it just gives you one advantage. Here, if I want to rotate that so it goes out straight, I have to right click, zoom pan, rotate, and then go down and pick the rotate view. But I can also go in and say I want to insert a drawing view that's relative to the model. I pick a front view. It pops over to the model again, but this time I can select its orientation when it comes in, and I can say I want that front view to be that face, and I'm going to change this from right to top, and I want the top view to be that face. And I'll do it again because I forgot to do one thing. So relative to model, there's my front. I need to have selected bodies identified here, and what I need to do is pick just that body if that's all I want to bring in. Now that comes in, and it comes in all by itself. I brought it in with the right view lined up with the face because it went back to the defaults when I went back in. But that's the same part now, and that part came in, and I can orient it when I first bring it in. And that's the overview, sort of introduction to Weldments. The other video is about 30 minutes long, how to create your own profiles, how to turn those into Weldments, and some things to watch out for. This one really, how to edit the Weldment itself, how to set it up in such a way that you have a cut list, how to bring that cut list into a drawing file. The one last thing I don't think I showed you yet is if I pick this view right here, make sure that the view lines up with the reference configuration that you wanted as welded, and make sure that the cut list does as well. But if you have an exploded configuration, you can check this off, and it'll actually show it exploded in the drawing file itself, and just explode it with all the dimensions showing. So you can explode it or not explode it, it's up to you. I'm going to end this one here.